Thank you for watching the presentation video of the Recap framework. This talk will introduce a novel media format called Recap. As it is a novel concept, we will first introduce what it is by giving concrete examples of recaps. Then, we discuss technical challenges and our Recap framework to aid the development. So, what is the Recap? Here are the example applications we built and open sourced as part of the framework website, showcasing dynamically generated animations, lyrics placed at the mouse cursor position, and the character dancing to the music whose appearance can be interactively customized. We define the Recap as novel interactive lyric-driven visual art, and within lyric apps, lyric and visual effects are synchronized with music playback and dynamically adapt to user input, such as mouse and touch interactions. Unlike lyric videos in which designers elaborate on a single version of static media, in lyric apps, the visual output needs to be generated on the fly by programmers' algorithms. As a representative example of a complete lyric app, let me show Miracle Universe by Miral. It displays lyrics in the immersive 3D space, and the character climbs a spiral staircase as the music plays. Clicking on the floating cubes allows the user to look at the character from various angles, and depending on the number of cubes clicked, the cherry blossoms may be half or fully bloom at the end. So this app achieves high precision multimedia synchronization, the lyrics are eye-catching, and a good amount of gameplay makes the user want to listen to the music repeatedly. A truly interactive application that can only be called a lyric app. It is already deployed as a production-ready web application, and you could try it out yourself. The previous example was from an annual Hatsune Miku Magical Mirai programming contest. We have been holding this since 2020 in collaboration with the company developing Hatsune Miku, a virtual singer and singing voice synthesizer for musicians. We collected 52 applications in 2 years and analyzed them for design space exploration and evaluation of the framework. We need to delegate the introduction of the results to the paper appendix due to time constraints, but we thoroughly analyzed them to confirm the low threshold and high ceiling of the framework, and to extract 8 representative categories. While there was such a diversity in the collected recaps, we are aware of the limitation of the contest format that prevents programmers from using experimental web APIs, such as Bluetooth APIs, and the kind of follow-up study should be interesting for future work. Given the introduction to lyric apps, let me move on to the lyric app framework we developed to aid the lyric app development. It provides an intelligent and flexible web-based workflow. The musician can upload a musical piece, or the programmer can choose one from existing online musical pieces on the web user interface. Then, a framework automatically analyzes musical elements such as lyrics timings, part of speech, musical beats, chorus segments, and so on. If there are errors in timing information, they can be corrected on the web user interface. Then, the programmer can develop applications with TextAlive App API, a JavaScript API to access analysis results and control music playback, which we will touch on later. Finally, the lyric apps can be customized and distributed to end users as production-ready websites. For the lyric app customization, we developed a tool named Lyric App Customizer with musicians as potential users in mind. It provides a graphical and intuitive web interface to customize existing lyric apps. Technically, during customization, it communicates with lyric apps in iframes by post-message API. Once the customization is done, the results can be stored as a query string to the lyric apps so that the musicians share the customized lyric apps for their musical pieces. Now, let me dig into the programming experience of an API named TextAlive App API. It is publicly available with API documentation, explanation videos, and open source examples on this website. It can be divided into 2 parts, which I will introduce one by one. This slide shows the former part, which is an event-driven API for state management. 2 key considerations to support lyric app development are shown here. The lyric apps can be designed for different sets of musical pieces and have different levels of end-user interactions. To exemplify these considerations, we show 3 examples from the programming contest. The first example is a virtual reality storytelling application. It is designed for specific music, and the scenery of a school classroom reflects the theme of the lyrics. For non-stop immersive experience, it doesn't allow pausing nor seeking in the musical piece. The second example is a music rhythm game where lyric phrases move from right to left, and the player needs to interactively move the virtual singer character to the appropriate position. It is designed to be played with a specific set of musical pieces, and the player can pause the game but cannot go back to the past. The third example is a music player application that technically supports any musical piece. The user can open an online musical piece of their choice, play it, pause it, and seek a specific position in the musical piece. To support these various use cases, we listed out all possible states in lyric apps and implemented API to control states such as request, play, pause, and seek methods, as well as to get state transitions by adding listeners to the playback events. The latter part of the API is a time-driven API for time-sensitive interactions. To program visual performances synchronized with music playback, programmers must write code that responds to various musical events such as beats, lyric bars, and changes in vocal amplitudes. While it seems straightforward to define event types for all these musical elements and allow writing on beat, on word, or on vocal amplitude update event listeners, we found it doesn't work well. For instance, the event-driven model does not go well with the feature planning. If we want to gradually show a lyric word, the program needs to start showing it well before it actually starts vocalizing. In addition, the event-driven model is not good at considering multiple kinds of musical elements to synthesize visuals. If we want to show the ripple effect synchronized with beats around the lyric word, the program must write 2 event listeners for word vocalization and beat events. Furthermore, the framework needs to implement an event loop to detect events, which caps the precision of the event interval. To address these issues, the time-driven API takes a straightforward form of functions taking playback position as a single argument. For future planning, the programmer can add an arbitrary amount of time such as 5 seconds to the argument. And to incorporate multiple musical elements, they simply need to call multiple methods and synthesize the results in their code. And as these methods can be called within the rendering loop, there is no issue regarding time precision. The source code analysis confirmed that this time-driven API works well with various code encoding libraries such as P5.js, 3.js, Create.js, and Pixie.js. In addition, many contestants used GUI libraries such as jQuery and React to help make the lyric apps interactive. Please see Appendix C for a complete list. The analysis even led us to come up with the improved API design, which is detailed in the paper. To conclude our presentation, let me discuss interesting perspectives on media technologies in the light of this work. Every artistic expression has evolved with media technologies. In the case of lyric-driven visual art, vinyl records and compact discs come with lyric sheets. After the rise of video sharing services, lyric videos became popular, which we previously supported with a work published at KAI 2015 named TextAlive. Nowadays, given that people have their smartphones to enjoy interactive experiences and share their experiences with others on social media network, lyric apps, as we define in this work, will follow. We feel proud that we pursued our work with the help of a community of programmers and musicians, and we believe that our framework will be an important milestone toward the vision. Throughout our work, we noticed the benefits and potentials of adding interactivity to existing media, musical pieces in our case. First, because the programmer can listen to musical pieces and get inspired, they can kickstart their creativity. Instead of working on something creative from scratch, they can borrow that part and kickstart their creation. Second, because the development of lyric apps is inherently the collaboration between programmers and musicians, programming activities can serve as new opportunities for communication between people. We observed some programmers contacted the original creators to better reflect their artistic intention, and we are happy that our deployment in the wild made it happen. Third, related to the deployment in the wild, we consider it important for computer scientists to place themselves in creative cultures and build a future together with the help of creative people with diverse technical backgrounds. There is a special interest group on this topic at this year's KAI. Also, a framework and an API are publicly available, so please try it and experience the world of lyric apps by yourself. Thank you for watching.